Okay, so hello and welcome to session 12, Time Flies. Today we're going to discuss reliability. And I hope that what we have discussed so far in the course have raised your awareness about how to run statistical analysis and how to interpret the output of statistical analysis. Reliability is one of those important topics that cuts across many, many different fields of research. So today we're going to talk about reliability. And I would expect that you guys will consider this as the second check that you will run on your data before you go ahead and run your multivariate analysis like ANOVA and t-tests. The first one being normality check. So the second one is going to be a reliability check. We haven't discussed reliability so far because, well, it's not very difficult to, fathom. It's kind of easy and straightforward, and interpretation of reliability is also straightforward and easy. So I thought to leave this for session 12. So you're just done with all sort of difficult statistical analyses like GLM, ANOVA or factorial ANOVA, and repeated measures ANOVA. And then you are just left with one easy analysis called reliability analysis. Let's go through it. It's actually quite fun. So this is where we are today, session 12. Okay. Reliability analysis is particularly important when you want to design a survey or a test. Let's say you want to design a survey of people's hatred or love for statistical analysis. For example, this is the one of the very kind of interesting questionnaires that has been designed for measuring people's hatred or love for statistics and mathematics. For example, look at the first factor, and I'll let you know what factors are later in this session. The first question is, I have never been good at mathematics. Well, this is one question. The second question is, it's quite interestingly worded, I slip into a coma whenever I see an equation, and I hope you don't. I did badly at mathematics at school. And so on and so forth. I mean, you have other, questions here. So the person who is going to answer this question is going to choose anything including strongly disagree, disagree, agree, strongly agree. Sometimes there's a neutral point right in between. For example, it says no idea or neutral or something like that. But most often, a lot of scholars say it's a good idea to use 4 categories or 6 categories where there is no neutral point, because if you have a neutral point, the person hides himself behind the neutral point. So he doesn't take any stance as to whether positive or negative. So it's a good idea to, at least some research shows that it's a good idea to remove that neutral point in between and just force them to choose something. Okay, so let me go back to my slides. That's one way, and by the way, that's one way, and this is called a Likert scale. Likert is the person who created it. There are different types of Likert scales. This is one type, which is quite commonly used, and I'm sure you have seen them in research. Okay, so the question is, this questionnaire, what does this questionnaire measure? And what is a questionnaire in the first place? Dornier and Taguchi in 2010 defined questionnaires as self-completed written questionnaire or surveys that respondents fill in by themselves. There are no correct or incorrect answers in a questionnaire. And by the way, let me again link it back to reliability. We need to know a little bit about questionnaires before we go ahead and talk about reliability. Because reliability is, like I said, is a very important attribute of tests and questionnaires. Now, questionnaires are employed as research instruments for measurement purposes. We want to collect reliable data and valid data. Thus, the term reliability. For validity, we will not cover it in this course. If anyone is interested in learning about validity, it's usually discussed in a course like language assessment. Okay, and Dornier in 2007 stated that it's all too easy to produce unreliable and invalid data by means of an ill-constructed questionnaire, meaning that developing a good questionnaire is not really an easy task. And once you develop a questionnaire, you need to know how to ascertain or estimate its reliability. Okay, so I'm going to share with you some hints about questionnaire developments, which I believe are quite useful, and they can allow you to think about questionnaire development within a useful theoretical framework. You know, there are different types of questionnaires: online questionnaires, paper-based questionnaires. They have pros and cons. And if you decide to create a questionnaire, always think about whether you need to use a paper-based questionnaire or an online questionnaire. An online questionnaire allows you to save a lot of time, because I have done both types of questionnaires, and if you give papers to your participants, then you have to sit down and transfer all the data to an Excel sheet or an SPSS file, which is going to take a huge amount of time. I wouldn't do that, honestly. So I would just perhaps provide an online questionnaire. You can use a simple Google Doc if you don't have access to all those websites that allow you to create a questionnaire. Also, by the way, Julian has created questionnaires, and she can share with you her experience. Okay, we have talked about sampling. After you create your questionnaire, you need to come up with a good sample. You remember that? Can anyone tell me what you remember from sampling, please? I don't think I hear anyone. What kind of samplings are there? I mean, the ones that we covered last session.
Just remember random sampling, cluster sampling, stratified.
Yeah, nice, good. So when you are doing where you're developing a questionnaire for a survey, you should use a good sampling technique, just pretty much like one of the sampling techniques we covered in previous sessions. And there's always the question of sample size. I mean, to be honest with you, it's a question that can't be answered very easily. So if you are developing a questionnaire, a rule of thumb is like this. Look at this questionnaire, okay? So we have got around 23 items, if I'm not wrong. I think so. I think 23 items. Okay. So a rule of thumb is like this. For 23, for each item, there should be 5 people in your sample. So for this questionnaire, you will need at least 115 people. This is one rule of thumb. Another one is, some people say, no, 10 would be better than 5, especially if you want to do reliability and validity analysis. And some people are like, no, 10 is not enough. It certainly has to be 20 items. So we have 3 different opinions about how many people can take a questionnaire. So this is going to be 230. This is going to be 460. You see, it makes a big difference. So this is rule of thumb 1. Rule of thumb 2 is actually, you can look at the reliability statistics. For example, you can run a reliability analysis on your questionnaire from whatever data you have. And you'll find out that, oh, the reliability is greater than or equal to 0.7. So that's more or less a good questionnaire and a good sample size. That's rule of thumb 2. These are not exact sciences, I should be honest with you, because when it comes to questionnaire development and validation, we do not have power analysis. That's the problem of questionnaires. And power analysis, which by the way is not covered in this course, but I thought to give you a brief overview in this slide, is usually used in GLM and t-tests. Okay, and power analysis allows you to think about the minimum sample size required for an experiment given a desired significance level and effect size. So let me quickly show you what I mean by this. I'm gonna open one of these data sets that we often use. Okay, this one. We have used this before. When you are running an ANOVA, by the way, today I'm using SPSS 28. I install SPSS 28. Previously, I was using 26. So there are some developments in SPSS 28, which is pretty interesting. So univariate analysis. Let's say my dependent variable is writing. My independent variable is, let me change these guys into display names, is stream. Okay. And under options, I clicked on options, estimate of effect size, observed power. So if I click on observed power, you can also check the rest of them. I'm not going to check the rest, just want to show you this one. Click continue. Okay. You see observed power is 1 here. So this is what we mean by power analysis. What does it mean? It means if power is 1, which is the maximum, max is 1, it means that you can rely on the results of your analysis because your sample has reached the minimum sample size. But if as power goes down, so here the amount of certainty is 100%. As the amount of power goes down, this amount of certainty also decreases. So if your power is 0.9, you have 90% of certainty in the results of your ANOVA test. Okay, that's one way of saying how reliable or how accurately done your analysis is, and whether the sample that you have collected is suitable for your data analysis or not. Is it okay? Meaning that you have collected a required sample size for your analysis. So far, can I check if everybody is clear so far? Any questions? Okay, I don't hear.
What is the value of power analysis to show that the effect size is not reliable? So the number one is maximum. So is there any value for?
Obviously, the lower it is, the worse your data results are. I haven't seen any thresholds, but what you can take into account is something around 70% as a rule of thumb. I mean, below which you can start to doubt the representativeness of your sample size. Because like I said, we're doing parametric analysis, and you always want to draw a conclusion from your sample, extrapolate from your sample to a population. So now if your power analysis returns a very small power, this extrapolation or generalization cannot be made with confidence. 90% is good. Even 80% is not too bad for our field. But I assume when you're hitting 60, 70% and below that, you start to doubt the results because this cannot be established. So as you see, I'm talking about a multifarious approach to statistical analysis in which not only the normality of your data is important, but also the power is also important. Of course, there is a connection between power and normality as well. The more normal your data looks like, the more resemblance you will find between your data and the population. That's a good thing, because then that allows you to have a higher power in your statistical analysis. So to not to digress from your question too much, personally, I don't think that there is any well-established power statistic. I mean, you can find different things in different papers, but the thing is, the higher the power, the better it is. Now, there is another, a software package. This is the symbol of the software package. It's called G-Power. Let me see if I have a copy on this computer or... no, I'm afraid I don't have G-Power on my computer. On this one, probably it's on another laptop. You can Google G-Power. G-Power is useful because it allows you to, you know, look into the sample size you need. SPSS doesn't give you that statistic, but G-Power does. So this is a very useful one. Okay. Oh, there's another person. Okay, guys. Any further questions before I move ahead?
I have G-Power on my laptop.
Oh, Julian. Okay. So if you think you can, I mean, if you find time, you can perhaps share your screen later just to show them how it works.
Okay.
Good. Because I think you're using it for your PhD data collection, right?
Yes, I used it to calculate the sample size I needed.
Great. So yeah, that's a great idea. Okay, guys. So how did those guys develop these 23 items and 4 factors? There are several steps. The first step is called construct definition. And actually, there's a lot more to it. But at the interest of time, I'm going to give you a little bit of information about it. I think this will be useful for you. Construct is anything that we want to measure. So things like attitude, motivation in applied linguistics, proficiency, because we can't immediately observe them, we need to develop an instrument to elicit some behavior which is related to these constructs. For this reason, we call it a construct. Sometimes it's called a latent trait. Latent means hidden, is something that's not immediately observable. So it's latent in the sense that we can't see it immediately. Latent trait, therefore, or construct. First of all, we need to define it. How do you define it? We need to develop a theoretical framework. Those of you who are taking language assessment are very well familiar with it. So got to go through the literature and find out how people have defined and measured attitude. So here I'm gonna provide you with a sample, an example. In one of the papers we published in what is it called? Computer Attitude Questionnaire. Aryadoust. If anyone is interested to look. Oh yeah, this is what I'm referring to. So if anyone is interested to learn more about questionnaire developments, this is a good paper to read. I mean, obviously I'm one of the authors. I shouldn't say this is a good paper. I leave the judgment to you, but you probably will learn one or two things from the paper. So validating a computer-assisted language learning attitude instrument. So here we defined attitude as a construct that has three sub-constructs or three components. So attitude. One is knowledge. Knowledge. One is emotions or feelings, or affect. Affect. And one is behavior. In other words, if I'm asking you about your attitude about this thing, whatever it is, cell phone or whatever, you can't tell me what your attitude is unless you know it first. So knowledge. Then after you know it and you work with it, you start to have some feelings about it. You say, I don't like it. I hate it, or I love it. So that's affect. And behavior is, what are you going to do with it then? Because I don't love it, I'm going to break it. You know, I'm just going to break it and throw it away. That's your behavior. Or because I love it, I'm going to recommend it to many people. That's my behavior towards it. So that's an attitude. Now, for each of these, we went through the literature, the published work, and we found how, or by using what sort of items people have measured attitude or emotions or behavior. So we developed items to test each of them, to measure these three components. And that became our questionnaire. Then we went through reliability analysis and validity. This step, I mean, the definition of what you want to measure is what I mean by construct definition. So you use a theoretical framework. This theoretical framework, these three components, came from another theoretical framework, which is known as the ABC model of perception, or ABC model of attitude. I mean, you can Google it, you'll find a lot about it. This is just an example, really. This is not the only available examples. There are 1,000,001 different examples to allow you to identify what your construct is. So the ABC model helped us to define attitude, following which we defined components of attitude, which are these three. And then we said, okay, now we know we have three components. We're not just going around and write random items. We need to write each item to measure one of these components. One item, each item measures one component. The most important thing here to take into account is that if you have three components, you should develop at least 3 items per each, at least 1, 2, 3. That's the minimum number of items, guys, because you cannot measure one component or one construct with one item. That's impossible. It's interesting to know that I have seen very good journal paper. I mean, papers published in very good journals in which the authors claim that they were measuring one construct using only one item. Well, in social sciences, it's impossible. Now, so for emotions, you also need to have at least 3 items. For knowledge, you also need to have at least 3 items. That's the minimum requirement. So sometimes you have more items for one construct. For example, you have 10 items in one, 3 items in another, 5 items in another. That's fine. You don't have to have this balance between the number of items. But the thing is, keep in mind the minimum number of items that you need to create. 2, after creating the items, then think about the sample size, which I mentioned before here. Okay, so that's the step 2. 3, of course, you need the sample. You need this sample. So you know the sample size. Now you should look for the sample. How do you do that? Using those sampling techniques that I mentioned. That will be 3, sampling. And then you, so now since I'm talking about 3, reliability will become the last step in this case. Previously, of course, I talked about sampling, but I didn't put it down. So I put it down now as the 3rd step, and the last step will be reliability analysis. In this case, it will be step 4. Okay, so that's basically construct definition. And I think I have also at the same time talked about construct operationalization. It's the realization of the construct in which you translate what you have defined into items. It might sound like a little bit of a bombastic word, operationalization. It may take some time for you to get your tongue around it and pronounce it. I mean, it took me some time. But ultimately, it's a very bombastic word just to say, I translate the definition into items. For example, I translate behavior into items. In other words, I need to create items, to write items that I believe measure behavior. And of course, following that, you should show them to experts. Say, for example, your professor or someone else in your field, say, could you please go through these items and perhaps give me some feedback on them? Do you think that they're really measuring attitude? Are these measuring behavior? Are these measuring emotions? Are these measuring knowledge, in your opinion? If not, can you correct them for me? This is expert judgment. So you really have to go through these steps. Now, in writing your items, you should make sure that your items are neutral, clear, concise, non-leading. Okay, and like I said, there's sufficient number of items. I've said this. Now there are 3 mistakes that people commit when they are developing items. So if you are developing items and if you have committed these mistakes, if you have collected data, even though after the analysis, reliability analysis of your data, you find out that there's a high reliability, that reliability itself is not very much reliable. Now, it might sound like contradictory. You might question, why would a high reliability index or statistic not mean a highly reliable instrument? Because it's very easy, as I will show you today, to get a high reliability index in many circumstances, even though there are problems and mistakes in your items. What matters is, in the first step, your items should be well written, because there is a saying in English that goes like this: garbage in, garbage out. If your items are not well thought out or not well planned, then the result of your analysis, whatever you have measured, is not reliable. So what should we do? There are 3 problems to avoid. Avoid double-barreled items, leading items, and loaded items. These 2 are very similar, so similar that sometimes you cannot even tell them apart. So what are these? Let me just go through it. You can look at examples in 7 up to 11 later when you have time during the breakout sessions. Okay, so what is a double-barreled item? It's very simple to recognize a double-barreled item. Those items that have got an and, then, or other conjunctions, subordinate conjunctions or coordinate conjunctions, superordinate conjunctions in them, are basically double-barreled items. Here are some examples for you. Look at this, the first one. It sounds like an innocuous item, but in fact, it's double-barreled. Students should have more classes about math and music. Can anyone tell me what the problem is here? Of course, it's a double-barreled item, but in simple terms, what would happen if someone answers this item? I'm still waiting.
I'm not sure, but I'm thinking that students who hold the idea that students should have more classes about math, but should not have more classes about music. It will be harder for them to make a choice. Like
Precisely.
if they just partially, agree with the statement.
Precisely, very well said. Actually, that's exactly the point. What if I believe that I should have 100,000 classes on music and 0 classes on math? How am I going to answer that question? So it convolutes the answer to the extent that it's not reliable. Therefore, it's double-barreled, meaning that it's testing 2 things, measuring 2 things at the same time. The second one, cars should be faster and safer. The problem?
Like still measuring 2 items.
Which are?
Which are the faster, speed, and safety.
Yeah, 2 very different things, right?
Yes.
Even if they're similar, they're not the same. Even if they were similar, they were not the same. They wouldn't be the same. So faster and safer, which one are you talking about? I think I care about safety. In fact, I believe cars should be slower. What if that's my opinion? Next, I'm satisfied with my pay and job conditions. The same thing, right? And job conditions. The third one, the fourth one, the government should spend less money on the military and more on education. Perhaps more on education. But if you're living in a country in which military might is very important, then a lot of people might say, no, military should be strong and powerful as anything else. So the government has to spend a lot of money on that. Education doesn't matter. Even for such a person, it's very difficult to choose the answer. And finally, this tool is interesting. Okay, that makes sense. Now you're making a double barrel by saying, and useful. No, not everything that's interesting is useful, or the other way around. Some mistakes in questionnaire developments are listed here. For example, you might have read a question like this. Do you do A more than B? It's like a tongue twister. You know, what do you mean? I do A more than B, yes, no. It's very difficult to understand. So it's a good idea to break it down into two separate items. For example, I use A often. I use A less frequently. Then I use B less frequently. I use B in this way and that way. Break them down into two separate items and measure them separately using separate items. And so here's another way of breaking it down. How often do you use A? Or how often do you use B? This is another solution. Now, loaded and leading items are pretty much similar to each other. Like I said before, they are loading or loaded in the sense that they are making the evaluation of the person swayed towards one particular direction. You don't give them any choices. You already decide for them that something is wrong or right, and then you only are asking them the amount of rightness or wrongness in that thing. That's what we mean by leading items. So let me give you examples. When you're saying, concerned parents use infant car seats, concerned parents is not a bad thing. I mean, it's not a bad idea to be concerned as a parent to some extent. So if you are, or even you are not a parent, and if you're answering this question, you might think so. You might think that I am a parent. I'm a concerned parent, of course. So yeah, I think so. Yeah, because I'm a concerned parent. So yes, I use infant car seats. I strongly agree with this. Or I would like to be recognized in the future to be a would-be parent who is concerned as well. I would like to say, yes, we should use infant car seats more often. So I would say strongly agree to this item, just because of this adjective. The item is loaded with some adjectives there, whereas the adjective should not be there. A better phraseology would be special car seats should be required for infant passengers. You know, something like that. Do you agree or disagree with that? Example 2. This is a very funny question, but don't be surprised to see this or similar questions on some questionnaires. How dumb is some politician when it comes to foreign policies? You see, there is also that leading adjective again. Sometimes it's an adverb, sometimes it's an adjective, meaning that you have already decided for the person, the respondent, that the politician in question is dumb. Don't even question that. I'm leading you towards that direction. So you're going to just say how dumb that person is, full stop. A better choice would be describe your politician's position on some foreign policy. Or do you agree with that politician's, how much do you agree with that politician's position on foreign policy? Strongly agree, strongly disagree, etc. And question 3, smart students should go to the library more often. this is like, yeah, of course, I'm a smart student, so why not? Again, there's an adjective there. So adjectives and adverbs. If you have adjectives and adverbs in a question, think about it more. Ask someone else to see what they think about it. Don't just throw in adverbs and adjectives into your questionnaires. That's like a rule of thumb for you. Loaded items, again, make the evaluation of the person or the response of a person sway towards one particular direction. Where do you enjoy studying mathematics? You might feel too shy to say, look, I don't even enjoy mathematics, or I don't study mathematics, or I hate mathematics. In this case, you should say, well, I enjoy studying mathematics in the library or somewhere. Whereas the truth is you're not even studying mathematics. So it's loaded. It's loaded with the assumption that the respondent enjoys studying math. Okay. So it's like another type of leading items, really. Instead of having one particular adjective or adverb, you have one particular phrase or something that leads the person towards an answer. So think about these more carefully when you're developing an answer, a questionnaire. Any questions so far? Okay, so everybody, now that we know how to develop a questionnaire, we're going to talk about reliabilities. Today, we're going to talk about internal reliability. That's the reliability of the items. Okay, external reliability usually refers to stability. So, you know, when it comes to reliability, remember one term before I translate, you know, interpret external and internal reliability. Always remember, reliability is about consistency or reproducibility. Consistency. Okay, so it could be consistency over time, consistency across groups, consistency across occasions, and so on and so forth. So it's a very important concept in instrument developments, and it's a precondition for validity. Now, let me tell you what external and internal reliabilities are. So external reliability refers to comparability between different uses of an instrument. For example, you have a test of writing, a writing test, and you know, writing is a subjective test. You may write a great essay and you give it to me and I flunk you. Say, no, this essay doesn't read well to me. So for some reasons, this is my disposition to be characteristically severe. I'm not, of course, don't freak out, but I'm just saying, to be characteristically severe when it comes to writing. So no matter how beautiful and elegant your essay is, I'm going to flunk you. But so that's rater one. That's me. Always severe, always angry. But there's another rater who is fine. He's not too severe, who's not too lenient. Actually, he's a fair person. So he's a little bit of smiley, not a too big smile. And there's even another person who's very lenient. No matter what rubbish I write, that person would give me an A+. So this is like a big smile, haha, like that. Okay, so it matters which one of these three guys scores my paper. Reliability, external reliability means that multiple raters would not interpret my essay in extremely different ways. In other words, if a person gives me a high score, the other person would also give me similar, if not exactly the same score. So if I get an A from a person another one might give me A plus, and another person might give me an A minus. It's still within A, but none of them will give me a C or a B. In this case, reliability is there. In this case, it's not. That's external reliability. It has to do with how another person evaluates your performance, evaluates what's going on in your brain or in your mind, if you will. Now, internal reliability is basically about the results of the questionnaire, particularly, and tests. So usually refers to questionnaires and tests. And it's measured by using different indices. One of them, which is very commonly used, is called Cronbach's. Cronbach's what? Let me see if you have read today's papers. Cronbach's. Cronbach's.
Alpha.
Alpha, very good. Cronbach's alpha. And something else that is not very commonly used in applied linguistics, but I'm going to show you today how to do it, is called McDonald's what? Omega. McDonald's Omega. This is a powerful one, and I would really love you guys to consider using McDonald's Omega for some very good reasons, which I will talk about today. So let's not spend too much time on the theoretical underpinnings of reliability and survey analysis. If you want to learn more about reliability analysis, this is another way of doing reliability analysis. Those of you who are also taking Rush measurement, the language assessment course, you remember that last session we talked about Rush measurement. Rush measurement also gives you a reliability index, which is very close to Cronbach's alpha. This book has been written by Thomas Eckes, and since we are talking about books and did I stop sharing? Sorry. Okay, so since we are talking about books, I would like to say that you can also look at our book. Thomas Eckes actually is my co-author, is my friend too. So he has written a book chapter for this book. Let me see if it's, gosh, we wrote it in 2019 and I've already forgotten the content. Anyway, so this is volume 2. No, he wrote that for volume 1. I'm going to go back to volume 1 and okay, in volume 1, he has written a book chapter, guys. Mr. Eckes, where are you? Here. Many facets Rush measurement. I mean, this is a more updated take on many facets Rush measurement, in which you can get a lot of interesting information about reliability analysis using a technique called Rush measurement if you want to know more about reliability analysis and instrument development. So you can read this chapter. Later on, if anyone is interested to read the chapter, I'm happy to send you a free copy of the chapter, provided that you just keep it to yourself. And in these 3 chapters as well, this is section 1, test development, reliability, and generalizability. You will also be able to see a lot of interesting facts and information about reliability analysis. So you can also take a look at these. There is a question for me, I think. I'd like to have a free copy. So, okay, Liang Li, maybe email me later. So I'll not forget it. I'll be happy to share a copy with you. Okay, so guys, let me go back to the slides. Okay, so let me just go to, I think I have talked about these. I'm not going to provide too much detail here because it will be confusing a little bit. Now, there is a smart guy called Mr. Crumbach who wrote a paper in 1951 and proposed his own alpha. He himself never called it Crumbach's alpha. He is really a modest man, but then people started to call it Crumbach's alpha. And later on, in more recently, in 2001 or 2004, he wrote a paper to say, please do not call it Crumbach's alpha and do not interpret it in this way. I'm not happy with the sort of things that you're doing with my alpha. But people said, okay, we're not going to call Crumbach's alpha anymore. But then no one honestly paid attention to it. It's still, to the present day, everybody still calls it Crumbach's alpha. Anyway, Crumbach's alpha is here to stay with us. But the name that he himself chose for it is coefficient alpha, or internal consistency coefficient alpha. What does it mean? It's basically, think about it in this way. It's like one index that summarizes the correlation between all of the items. Right? Do you remember correlation analysis? If I go to the sample that we're going to use today, in this data set, you can run a correlation analysis by going through the correlate by variate and just throwing everything into the correlation side and click OK to get the correlation coefficient for each of the items. It's still running. It's running it. It's a bit slow. Anyway, so once you got the correlation, you will get a big matrix of correlation. Some of the correlations are high, some of them are low, and so on. Here it is. You see the correlations. This is a big matrix. It's really too large, and I don't like the way that it has been shown. But anyway, so question 1 with 1 has got a correlation of 1. Question 1 with 2, a correlation of minus 0.099, and so on. Now, as you see, some of these items have a high correlation, and some of them have a low correlation. But if I ask you all together, do these items correlate well or not, then you don't have any answers for me. I say, I don't know really, because some of them are high in correlation, some of them are low in correlations. So in a sense, Crumbach's alpha allows you to come up with one neat and tidy, neat way of representing that huge correlation matrix, and gives you one index that's very easy to interpret. Okay, keep that in mind. That's one thing to know about internal or Crumbach's alpha reliability. The other thing to know is you can also identify which one of these items that you have in your instrument is not statistically related to the rest of the items. So if you have, let's say, 1, 2, 3, 4, and 5 items, and you have a Crumbach alpha of 0.7, which is not too bad, you can also investigate what happens if I remove one item at a time and investigate Crumbach's alpha. Then you can find out what happens if item 1 is dropped. What happens to Crumbach's alpha? So you might, find that if you drop item number 1, 0.7 also drops to 0.65. So you would say, if I remove item number 1 and my Crumbach's alpha drops to 0.65, question for you guys. Is it a good idea to remove item 1 or not? No, because? Very obvious, right? Because Chromebox Alpha drops. We don't want Chromebox Alpha to drop. Now, what if I remove, let's say randomly, I'm going to randomly choose number 4. I remove item 4 and my Chromebox Alpha value increases to 0.79. What should I do now? I drop item 4 and Chromebox Alpha jumped up. Conclusion?
Should drop.
Yeah. A better idea to drop it. A correlation analysis doesn't give you this information though. Chromebox Alpha does. I mean, Chromebox Alpha analysis does. All right, so there's one more thing here. It's about, so what does internal consistency mean? It's the opposite of error. In other words, if you have high reliability, you have low error. What does it mean? Have you ever played darts, guys? Have you done that? You know, you have a target and you throw your darts and you're hoping that you will hit the bull's eyes right at the center, right here. Now, that's your target. Now, reliability can be defined in this way. If your dots fall all over your darts fall all over the place, one falls here, one here, one here, one there, one there, one there, you have not been able to reliably show your ability in throwing darts because your darts randomly fall on literally every space on the wall. Sometimes it's the bull eyes, sometimes it's in the corner, sometimes it's in the last orbit. I cannot rely on your abilities. But if you consistently do something similar, do you remember consistency? If you consistently do something similar, for example, you fall here, there, you know, more or less in similar areas, I can rely on this. Now, so these are like items. Items are measuring the same thing consistently. But if sometime one of the items falls outside, like here, then this item is not a very reliable measurement for what we are measuring. It's not a bad item. It could be a good item for measuring something else, not for what I am measuring now. Okay? So Chromebox Alpha allows you to identify those items that cluster together and those items that don't. It ranges between 0 and 1, with those indices that are closer to 1 being a better set of items in terms of their consistency or reliability. Finally, I would like to say a few words about how to interpret Chromebox Alpha. You know, in classical test theory, CTC, on which Chromebox Alpha analysis is based. I mean, now you might be asking, what is classical test theory? That opens a can of worms. Let's not go that way for the time being. Just remember this formula. Any score that you achieve on a test or a questionnaire, whatever that score is, it is consisted of two parts. One part is the observed score, and one part is the error. So if I give you, and this is the truth, guys, if I give you an A, this is your observed score, but there is some error in that score. We don't know how much error there is in that score. But if you run a Chromebox alpha analysis on all of the scores I have given, then I can find out that on average, how much error there is and how much reliable score there is. You know, so on average. Now, if Chromebox alpha is not 0.9, 0.90 or 9, this is the amount that is reliable, and 10% is error. If Chromebox alpha is 0.7, then error is how much? How much will be the error?
20%.
Sorry?
30%.
Absolutely. Now, is 30% too much? Well, I will let you know if that's too much or not in a minute. So this is how you can interpret Chromebox alpha more accurately. So let's say your Chromebox alpha is not 0.9. Then 90% of the variance in observed scores can be accounted for by, or can be attributed to, the variance in the test taker's true score, true ability. Okay, now forget about this. I mean, let's just forget this constructed relevant variance. Let's forget it. With 10% of the variance accounted for by measurement error. Let's forget about this as well. I mean, let's not make it too technical. I think this is just pretty good enough. And I'd be honest with you, many people who run Chromebox alpha analysis in their papers do not even explain this much. But you can take this into account. Whenever you have a Chromebox alpha value, this is one of the ways that you can interpret Chromebox alpha. Now, there are some important facts about Chromebox alpha that we need to know before we start running the analysis, okay? Here's the thing. If your sample size, your correlation, or the variance of your data are not great, Chromebox alpha is going to be low. Why is it so? I'm not going to go through too much mathematics, but if you look at the formula, the algebraic formula for Chromebox alpha, you'll find that there is an average variance, or V bar, in the formula. There's an average covariance, or C bar, in the formula. Covariance and correlations are very similar. Covariance is non-standardized, correlation is standardized relationships between items. There are two ways, by the way, for estimating Chromebox alpha. One way is by using covariance. One way is by using correlations. SPSS can provide you with both. The point is, regardless of which one you use, if the correlations and covariances are low, and if you have a small variance in your data, then your Chromebox alpha is going to be small. It's going to be low. An immediate conclusion from this discussion is a lot of people think that when Chromebox alpha is low, your instrument is bad. Not necessarily, not always. It could mean that variance in your data is low. Why? And what does that mean? If everyone who is answering my test items or answering my survey thinks in more or less the same way, everybody chooses strongly agree, agree, strongly agree, agree. There is little variance in their answers, right? Everybody is clustering around strongly agree and agree in around 1 point or 2 points there. So there is little variance. If everybody thinks in the same way and answers in exactly this, more or less the same way, the variance shrinks, and so does Chromebox alpha. Reliability drops suddenly. Okay, so that's one indicator that low reliability could be one indicator that your variance is pretty small in your data. Now I want to open a bracket here. That's why I do not like situations, contexts. I don't know anything in which everybody is thinking in exactly the same way, or everybody has exactly the same ability level. I don't think that that's a natural way of, for example, doing education or teaching or learning. There must be a good variance in everything, more or less. All right, so can I also share this with you, and then we will go to item analysis. If your Chromebox alpha is low, it might be that you have only few items about which everyone is thinking in exactly the same way. For example, you only have 3, the bare minimum number of items. Why don't you increase the number of items and see if Chromebox alpha is going to increase or not? That's one way. Sometimes you have many items. So, sorry, someone is asking a question? No? Sometimes we have so many items or many items on the questionnaire or the test, so the reliability increases. And like I said, Chromebox alpha depends on average correlation. It also depends on item discrimination. I'm not going to go through details of item discrimination today. If we find time, I'll talk about it later at the end of the session, but keep this in mind. Like I said, another option is McDonald's Omega by Mr. McDonald. This is a very good option that you can also choose over Chromebox alpha. In SPSS 28, I'm delighted to say that they have finally included Omega to keep up with Joneses. Why? Because I am sure that they have seen that there are a lot of new software packages that are coming up, and a lot of people are migrating from SPSS to them. I think this is an attempt to bring them back to SPSS and say, look, if those free software packages are offering hierarchical coefficient Omega, we have also included Omega in our SPSS 28. Well, the JASP software that I introduced to you in one of the last sessions has got a lot of very interesting and cool ways of doing analysis, including Chromebox alpha and Omega, etc. Anyway, so if your Chromebox alpha, long story short, is small, do not jump into the conclusion that my data is not reliable. That may not be the reason. It could be that your sample size is small, the number of items is low, the variance is small, the correlation between items is low. So you need to figure out what is causing this low Chromebox alpha. Okay, let's just move on. How to interpret Chromebox alpha? I have one answer, but it's disappointing. Nobody knows how to nobody knows how to interpret Chromebox alpha. Now, what is my evidence to support my claim? This wonderful paper. Taber in 2016 ran an analysis on the papers that have reported Chromebox alpha. So you see, he assumed that people are kind of in agreement about what is high or relatively high Chromebox alpha value, but then, much to his consternation, a lot of different opinions emerged from the literature. For example, people found that people claimed in their papers that a range between 0.7 and 0.77 is relatively high. Whereas there was another group of people who said 0.71 to 0.91 is good. So is good and relatively high the same or not? 0.68 is relatively low. Now, 0.67 to 0.87 is reasonable. And it's contradictory, at least. If you compare 9 and 10, you know, if 0.68 is slightly low, it cannot be reasonable. I mean, 0.67 cannot be reasonable. And so on and so forth. You can go through the rest of it. However, this may kind of be a solution that a lot of people believe can work, but sometimes people want to just save their paper. So even though they don't get a high index of Chromebox alpha, for example, when they get a 0.64, they say, well, it's adequate. Not too bad, it's adequate. Anyway, this is not a bad idea. I mean, this is good. If your Chromebox alpha value falls between 0.7 and 1, it's high. Chromebox himself does not agree with this. And in his paper, he categorically opposed these kind of rules of thumbs or criteria that anyone establishes. He said, as to whether Chromebox alpha is high or low depends on the purpose of the test. But he did say that in many situations, Chromebox alpha should be at least 0.8. But no one, very ironically, no one seems to take this into account. And in applied linguistics, many people, for unknown reasons, at least unknown to me, believe that a Chromebox alpha of 0.7 to 1 is high, and that's good. So it's acceptable, it's fine. You can get away with it if you've got 0.7. In many fields, 0.8 is necessary, though. Now you should make a choice in your papers and justify why you chose that. That's how research is done, you know. So a medium is between 0.5 and 0.7, low is between 0.3 and 0.5, and poor is anything that falls below 0.3. Yeah. Any questions so far, guys?
So can I know the source of the range?
Yeah, actually, if you read the papers assigned to you, they provide you with a lot of resources. So I do not intentionally, I do not provide the sources. I want to push you guys to go back to those sources. I know there's a lot of information in those sources, I admit it, but it's always good to go back to those sources and refresh your memories of those sources. So if you find it, let me know. Okay, guys, so I would like to go through these data here, but before that, why not we take a break for 15 minutes before we start hands-on? Okay, so I'm gonna stop here and we come back at 7:30. Okay, everybody?
Yeah.
Good. See you at 7:30. So I'm gonna continue with our analysis. Could you open this file, please? It's an SPSS file called factor analysis. Sorry, let's start from this one. Week 12, items attitude towards statistics. Okay, so we will run the analysis on this first to see what we will get. This is the data. Okay, can I assume that everybody has opened the file? I'm gonna toggle to the variable view. In the variable view, you can see the items and the labels. The labels are quite interesting. These are the items themselves. Statistics makes me cry. I mean, it's a funny instrument, but all computers hate me. I mean, this is a metaphorical way to say that I hate computers, or I cannot use computers. Our computers are out to get me. This is a funny way of saying that computers, I'm not good at computers, at using computers, as easy as that. SPSS always crashes when I try to use it. Okay, that's, you know what that means, right? I can't sleep for thoughts of eigenvectors. Okay, so eigenvector is something that's used in statistics. It's used in factor analysis as an example. Now, I can't sleep is a negative item. Remember, if you have negatively worded items like this, and if the rest of the items are positive in that scale, you should reverse code that item. We will look into reverse coding later, how to do it in SPSS, but theoretically, this is what reverse coding means. So I call it RC, reverse coding. Reverse coding, let me just spell it out. Reverse coding is easier. Is like this. If the answer is 1, so answers are 1, 2, 3, 4. 1 stands for strongly disagree, disagree, agree, strongly agree. Okay, 1, 2, 3, 4. So this is the direction of the so-called the construct. It starts from strongly disagree, which is the lowest amount of endorsement. 2 is slightly more, higher level of endorsement. 3 is a higher, relatively higher level of endorsement, and 4 is the highest amount or level of endorsement. Now, if someone endorsed the item by giving it a 2, when you reverse code it, 2, okay, so you reverse coding this way, 1, 2, 3, 4. Reverse coding will become 4, 3, 2, 1. So if someone give it a 2, you have to reverse code it into a 3. If they give it a 3, you have to reverse code it into a 2, and so on. When do we do this? When the item or question, by item I mean the question, is negatively worded. If one item is negatively worded and the rest of the items are positively worded. Because if it's negative, the lower score means higher score if you compare it with the rest of the items. If that's a bit difficult to keep in mind, just remember this rule. If the item is negatively worded before you analyze the data, you should do a reverse coding first. Okay, so keep this in mind and let's go back to the analysis. Some of these items are negative like this one. Now the scale, I'm going to click on this 3 dots and you'll get the scale. The scale is strongly agree is 1. Oh, so it's the other way around. It doesn't matter really, but most often when you give it, you arrange them in the opposite direction, meaning that strongly disagree will be 1, then disagree, then neither. This is one of the things that I said is not suggested to use, but they have used it. Well, no problem. I prefer not to use neither. Agree is a 2, and strongly agree is a 1. Okay, now how to analyze the data. First of all, I need to go to analyze, go all the way down to scale. Okay, under scale, reliability analysis. Click, and this window pops up. Let me reset it. Okay. So far, so good. No problems. It's very straightforward. It's under scale. And these are my items. Now, there's one important factor, guys. And I want to link this back to your slides that I was talking about. You know, instrument development has got construct definition and construct operationalization, if you recall, right? And I said that when you are developing the construct, you need to have a definition like this. You need to identify the components, 1, 2, 3. Now, in Cronbach's alpha analysis or reliability analysis, each component should be analyzed separately. So you need to figure out which items measure knowledge and analyze them separately first. So this is going to be analysis 1. Which items measure emotion or affect and analyze it in the second step. And here, in the same way, for behavior, you analyze them in the third step. What does it mean? It means that in this questionnaire, how many times should I run Cronbach's alpha analysis, guys? Look at the questionnaire. It's got 4 categories.
4 times.
Exactly. So the first time on factor 1, that's fear of math. It's got only 3 items. Like I said, it's not okay. It's okay if you do not have consistency in the number of items measuring the construct. The second construct is fear of statistics, and it is 8. It consists of 8 items. The third one is the fear of computers and consists of 7 items. And factor 4, fear of peer evaluation, it consists of 5 items. So let's do this. For the first analysis, what items do I enter? 8, 17, and 11. Let's do that. Let's go back to this. Right click, display names. It's going to be easier. 8. I'm going to hit Control on my keyboard. 8, 11, and 17. Was it 17? Yes. So these 3, and move it to items. Okay, guys? Or you can just move them one by one. Next is, I suggest that you go to statistics. You get descriptives for scale if item deleted. Why do we want to do this? It's very easy. I'm going back to what I said before. And that's, where is it? It's in the slide. I need to find that slide for you so you can create a connection between all the dots I have put on the compass here. Like I said, you can figure out if any of the items deleted, would that affect Cronbach's alpha or not? Would Cronbach's alpha would decrease or increase? This is how you can do it in SPSS by clicking this. Scale if item deleted. Can you see that? The other thing is that, again, let me link it back to what I said before about the formula of Cronbach's alpha. If you recall, I said in doing Cronbach's alpha analysis, you can either use correlations or covariances here. These 2, right? Either this or that. Which one should we use? SPSS gives you both options. You want to do correlations, or you want to do covariances. For the time being, I think correlations would be fine, really. Okay, so this is all we want. Correlation, I think, is better. So correlation and scale, and click continue. Now under model, you can click on this and it gives you alpha. It's Cronbach's alpha. Omega may be absent in your SPSS. Some of you may not have it because you might be using a lower version of SPSS. My 26 version didn't have omega. Suddenly 28, which I installed today, has got it. So for the time being, let's just stick with alpha. Let me remind you that we are doing the analysis on the first factor only. 1 factor at a time. Are you ready? There we go. Okay. Now here is the output there's not much output really. It's very easy to make sense of our analysis. So we have the case processing summary. It just tells us that there were 2571 people in the analysis, which is a huge sample size, which is pretty good, very good. Now, Chromebox alpha is 0.819, and it also gives us another Chromebox alpha, which is 0.819, which is the same. This is the middle one. Where is it? The middle one is basically, anyway, the middle one is basically Chromebox alpha based on correlation. If you recall, I clicked correlation, so I got this correlation. And the number of items is 3. Chromebox alpha based on, perhaps this is not correlation, perhaps this is covariance. But the one that we should report in our papers is this one. Chromebox alpha based on standardized items. Standardized means correlations. This is a cool thing about SPSS 28. You can just, add on to the values. You can add on to the width of the column actually. So, for example, maximum number of labels can be 2, 3. It's very interesting. Anyway, and now we also have a correlation matrix. It's the correlation between items. I suggest that you just move on. But sometimes here is how you can, if you don't have a very low Chromebox alpha, you can move on from this and go to the item total statistics. But if you have a low Chromebox alpha, what you could do is to look for a negative correlation. If one of the items has a negative correlation with the rest of the items, that item should be reverse coded or should be removed. So you need to figure out which one is the best solution, removing it or reverse coding it. I suggest that you first reverse code that item, and I'll show you how to do it. You don't have to do it manually. It's very easy to do in SPSS. You first reverse code it, and if it's still not okay, just drop it and run the analysis again. Now, the other thing is this value, these values, this column, Chromebox alpha if item deleted. It's very useful. So if item 1 is deleted, Chromebox alpha drops. Item 11 deleted also results in the dropping of Chromebox alpha value, and in the same way item 17 if dropped, this one, yes, item 17 if dropped results in the decrease, significant decrease of Chromebox alpha value. Should I drop any of these items therefore? You got the Chromebox alpha, this. Should I drop any of them?
No.
No, because Chromebox alpha drops if I drop them. Now, I would like you guys to run the analysis individually, to run the analysis on factor 2. I'm going to give you 3 minutes. I think 3 minutes should be fine. Quickly. Your time starts from now. So we're going to resume recording and see what you got. What is the statistic that you got? What is the Chromebox alpha value? I can't hear.
605.
6?
0.05.
Is that
0.605.
okay, so you got the same number. Now, do you think you should remove any items?
Yes.
What item?
Standard deviation. Standard deviations excite me.
Okay.
Question number 3.
Why is it so?
The alpha increases when the item is deleted.
To what? Increases to what?
Increases to 0.8.
Okay. But do you know the reason why it increases? I expect that you guys be able to answer this question. It's in the content of the questions. Look at the questions. Compare that item with the rest of the questions. Do you see any difference in them?
Reverse phrase.
Negatively worded.
Okay.
So that it excites me, but actually the component is fear.
Say it again, please.
Of the content is standard deviation excite me, but the content of the component for factor 2 is about fear of statistics. So the content, the item is reverse the content of the component.
Nice. So do we need to reverse code it before we drop it? The reverse coding applies here too, because the rest of the items are negatively worded, even though we don't have don't and not. Look, the content is about something negative, emotionally intense situation, in other words. So I wake up under my duvet thinking that I'm trapped under a normal distribution. It just shows how much hatred this person has for for normal distributions or statistics in general. So it's negative. This one is negative, but it doesn't. You see, it doesn't. So it's negative, 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 but positive. So there's one item that is standing out among the rest of the items, which has a positive connotation attached to it. It must be reverse coded. So how do we reverse code? Okay, before that, I want to run the analysis once. Analyze. Just want to keep this here so I can see the number of items. Where is that? Where is scale? Reliability analysis, reset. Okay, so items 21. Okay, 3, 12. Where is it? 12, 16. Good.
20.
20.
4.
Yeah, 4.
1. 5.
And 5. Statistics. I wanted to do correlations in this. And I think that should be good enough for our analysis. Chromebox alpha. Chromebox is this. Chromebox value is 0.69. Now look at the correlations. We have a negative correlation. So something is going in the opposite direction of the rest of the items. If items go up, this one goes down. If this one goes down, the rest of the items go up, and the other way around. So we have one piece of evidence that this item is kind of acting up. And when we look at the Chromebox alpha value, if the item is dropped, you see everything else decreases the Chromebox alpha value, but item standard deviations excite me increases it. So we need to do a reverse coding. How do we do this? Go to data. Sorry, transform. Okay. recode into different variables. Click on it. Good. Now you should find that item here. What item was it again? Item 3, this one. Move it to this side. Okay, so you have the item converted to, that's the direction, converted to something. We need to give a name for it. So I'm going to give the name Q3 underline R. That means reverse coded. And you don't need a label really. Just click on change, then you'll get it. Now, old value and new values, you click on this. So now we have value 1, change 1 to 5. Am I right to think so? Yes. There's 6 categories. Yes. So 1 to 5, 2 to 4. Well, 3 is 3, so we don't change it. Neutral is always neutral. 4 to 2. 5 to what? To 1. So if you're confused, you can write it down. You can write 1, 2, 3, 4, 5, and in front of it, write 5, 4, 2, 1. 5, 4, 3, 2, 1, of course, but then you don't need the 3 because it's going to be redundant. And click continue. And click OK. Now, hopefully we can see that new item. Go back to your data, and you see at the end of your data, you have a new item here, question 3. And if you go back to the data view, you can see, oh, 3 has not been converted. Sorry, we should have included 3. I thought it will automatically do it. So let's go back to recode into, and we got this. Just click on all the new values. Now what we need to do is to get 3 and just write 3, add. So this is what we do, continue. It's gonna overwrite Q3R, and I think we'll get a message probably. Oh yeah, we didn't get it. Okay, so sometimes the message pops up. Anyway, I'm gonna toggle back to my data, and you see the data has been overwritten. We don't have any values that are missing, probably. Yeah, we don't seem to have any missing values. Very good. Now, I'm going to quickly run the analysis with this. You guys should also do the same thing. Reliability analysis, remove Q3, bring in Q3R. The rest of the statistics remain the same. Click OK, and there you got it. Chromebox alpha has jumped to 0.821, even more than what was expected. And there is no negative correlation anymore. Very good. And here, if Chromebox alpha is dropped, sorry, if item is dropped, Chromebox alpha will all go down in all cases, even in this case. Is that fine, guys? Did you understand how to do it and how to do the reverse coding? Do you have any questions before I move on to the next point, to my next question?
Yes, Doctor. I'm sorry.
Okay, you
Doctor,
can.
how you go on?
Okay, it's okay. Ask your question one by one. I'll answer all of them. Go ahead.
Nita, you can go first. Right?
Oh, sorry for that. So Dr. Vahid, if we only have the items of the questionnaire, but before we collect data from our participants, could we run the test, run the analysis, or we need to get their responses, get their data, and to run this?
Very good question. What do you think?
I think we need, because when we do the reverse coding, I can see like the change of the data set for this specific item.
Yeah, statistical analysis always needs data. Regardless of what analysis you do, we always need data to run the analysis. So without having that data set, we can't really have any takes on the statistical representation of your data. So to answer your question, yes, we do need the data first.
But for the Chromebox Alpha, we use it to check the reliability of the items, not the readers, not the participants' response to the items. So that's my concern. So items are here, not changed. Yeah. But what is changed here is how our participants respond to specific items. So I don't know.
You raise a very interesting question. It's kind of customary in applied linguistics and even language testing to hear that Chromebox Alpha is about the reliability of the instrument or the reliability of the questions. Whereas in reality, Chromebox Alpha is about the reliability of the data, of this data.
Yes.
Of this data, right? So it will be more precise to say the reliability of the data, but it's very ironic to know that if you write this in a paper, I'm sure reviewers will attack you and would say, no, it's the reliability of the instrument. That's wrong, actually. It's the reliability of the data. That's why if you're using a questionnaire in context A, if it has a high reliability, it doesn't mean that if you use it in context B, it's going to have a high reliability, because the data changes from context A to context B. The questionnaire remains the same, but the data that you'll collect will be different. So it's important, it's important to stress that this is the reliability of the data that was collected through that questionnaire. Now, of course, SPSS doesn't know where the data comes from. It only looks at the correlations of the items and runs the analysis. So if you have a negative correlation in your data, it's going to affect your Chromebox Alpha value, the way that you saw it. So
and also SPS didn't show that the semantic analysis, like after we get the negative value, actually read back to the context of that specific item. So we see the question 3, the standard deviation excite me. So we actually do a little semantic analysis and to see what's wrong with this item.
Precisely.
But SPSS didn't do that for us.
Yeah, SPSS doesn't do it. Of course, I should also stress that it's not a bad idea to have a negatively worded item always. You can, because later on you can reverse code the data. Why do we use a negatively worded item or a positively worded item like this among other items which are otherwise negatively worded? The reason is it's like a trap. Sometimes we want to make sure that participants really read our items and choose an answer. If someone doesn't read it, or a number of our participants do not read it and just choose, because they don't have enough time, they just strongly agree, disagree, strongly agree, and all the way down. If they answer item 3 in the same way that they answered the rest of the items, then that's a red flag. It probably means, if standard deviations excite you, but if you also say that standard deviation, I hate standard deviations in another item, then it doesn't make sense. If you choose strongly agree for both of these items, it doesn't make sense. So it's not a bad idea to have a negatively worded item. SPSS is not privy to that, of course, because it doesn't read your items, but SPSS looks at your data. So it gives you correlations. And based on correlations, you can decide whether one of your items has a problem or not. The most important thing here, I should tell you, is the correlation, not the content. When it comes to reverse coding, if the correlation is fine, if it's not negative, you don't really need to reverse code it. We do reverse coding only if there is a negative correlation. And not low correlation, by the way, negative correlation. The sign should change to negative.
But can SPSS help us identify the leading item, loaded item, and the double-barreled items for us?
I'm afraid no. And actually, that brings me to my next question for you guys, but I'm gonna ask that question later because I think there were one or two more questions. So before I ask my question, I'm gonna invite the rest of the questions first. Does anyone else have any questions?
Yes, I did not clearly understand at this step of changing 1 to 2 or 3 or 2 to 3, because is there any rule to?
Oh yeah, sure. So if you, let's say you want to do reverse coding, okay? And your code here, actually that's a very easy one, so don't worry about it. Your code is this, you go to variable view and values and click on the code you have. You see it ranges from 1 to 5. 9 is no answer, it means it's missing, so just forget 9. So 1 to 5. It strongly agree, whatever they are. So I'm going to write it down here. 1, 2, 3, 4, 5. Okay. Now I want to reverse code it. I'm going to write it the other way around. 1, 2, 3, 4, 5. What does it mean? It means I'm going to ask SPSS to convert 1 to 5, 2 to 4, 3 to 3, 4 to 2, and 5 to 1. How do I do this? Through reverse coding. Let me go back to reverse coding, transform, code into different variables, move in that item. This is Q3. It was right here, so I moved it here. And I chose a label for it, QR. Then I click change. It was changed into Q3R and old and new values. Now here I said if it's 1, change it to 5.
Dr. Vahid,
like here. Yes.
but when I did the change for this question 3, right, the measurement didn't remain as ordinal. I think it changed to nominal instead.
That's fine. I mean,
okay,
I think mine might have also changed to nominal, probably.
Okay.
Yeah, it's fine. You can just change it into ordinal.
Okay, thank you.
No problem. It doesn't affect the results, by the way. Okay. Any other questions, guys? By the way, did I answer your question, Tanha? Did I?
Yeah. So after we do the reverse process like this, we need to reword the item. We need to reword the item.
You don't need to reword the item. Just you can keep it as is. Just operate on the data. So you add in another item here. You call it Q3R. And you just work with this item from here onwards. If you want to do any further analysis, you just use that. But just keep the item as is, really. You can keep it as negative or positive. That's absolutely fine.
Sorry, Dr. Vahid, I have a question.
Sure.
So what's the difference between the reliability of the instrument and the reliability of data? So if it's not reliable, it doesn't matter whether it's like not reliable about of the data or the instrument, right?
Yeah, I understand. That's a great question. You know, it's really technically not correct to say, and I might have been saying reliability of the instrument, but it's not correct to say the reliability of the instrument or the reliability of the questionnaire or the reliability of the test. Technically is not correct. But a lot of people say the reliability of the instrument or the questionnaire was whatever, was 0.9, for example. So the difference remains that in whether it's correct or not correct. It's not correct to say the reliability of the instrument. It is correct to say the reliability of the data collected through the administration of the instrument. That's the most correct form of it. The reliability of the data collected through the administration of the instrument. That's the more technical and accurate way of saying it. But again, like I said, you know, sometimes there is a common error in a field. It's so common that you also do not, I mean, take it for granted and just use the same common error that's used by everyone else.
Also, Dr. Vahid, I have another question, because in
Sure.
that case, we get the ordinal data, we got the variables are ordinal. So when we do the reverse coding, but for the ordinal scan, ordinal ways of measurement, the intervals between each point is not necessarily equal. But when we do the reverse coding, we are assuming that they are equal. That's problematic, I think.
So I think we are not, that's a good question. We're not making that assumption. What we are saying is whenever you see a 2, just convert it into a 4 as an example. We're not really making any assumption about whether the distances between the categories are the same or not. I mean, it just remains, statistically, it doesn't matter if you use 1 or 4. Where it matters is when you are doing a correlation analysis. So if all of the items have been written such that 3 means higher amount of the construct and 1 means lower amounts of construct, but if there is an item where this relationship is reverse, you have to reverse it back. Otherwise, anything that you will get will be flipped upside down. We don't want that upside down to happen. We want to correct it back, just pretty much like every other items. So it's like, let me give you an example. Every item on your test is like this. This is item 1. This is item 2. This is item 3, and so on. But this is item 4. You know, it's item 4. So you want to reverse code this guy. Flip him upside down again. I mean, it's his upside down, flip him back up. So he will become like the rest of the items, like that. So this will be item 4, reverse coded. That's the only thing we do, really. We don't do anything else to it. So the numbers will remain the same. The differences, whatever they are, remain the same. We just rename the categories. That's all we do. Okay, guys, so if you don't have any further questions, let's do some hands-on. We're gonna open the breakout rooms, and I'm gonna give you 7 minutes. Really, we don't have much time to do this. Maybe, yeah, 7 minutes is fine. Okay, Julian, can you open breakout rooms?
Yes.
Good. So the question.
Please co-host me first.
Okay, I think I've done that, but oh, you were.
I dropped out.
You were dropped out. Where are the participants? Julian, you are the co-host. Okay, good. There you go. Okay, as you are preparing this, guys, remember what I would like you to do is to do a Chromebox alpha analysis on factor 3 on these items separately, and number 4, wherever you need a reverse coding, please carry it out. That's one thing. 2, if you need to drop an item, please drop it and rerun the analysis. How do we know if you want to drop an item? We look at the Chromebox alpha if item dropped and its correlation. If the correlation is not negative, but if the item dropped, the Chromebox alpha value, if item dropped is low, then we drop it. It's high, sorry. Did I confuse you? So if if the, let me write it down here for you. If correlation positive, how to drop an item. Okay, 1, correlation is positive, but alpha, if item dropped, goes up. So if we have these two conditions, both of them, then item should be dropped. Okay, keep this in mind. Take a photo of it. If you think you will not remember this, take a photo of it. And Julian, can you open the breakout rooms?
Yes, we will be
7 minutes.
having 5 breakout rooms.
Sure. So 7 minutes, please.
Okay.
All the best, guys.
Are we supposed to be back within 7 minutes?
Yes.
Right?
Yeah.
Okay, so we're at the right place. Okay, I guess we need to wait for a while or a couple of minutes.
Sure.
So did you guys finish both of the 2 tasks or just one?
2.
Both.
That's one of them.
Just one of them. Did you drop any items?
Yes.
Oh, you dropped some items. Which
Question.
one item did you drop?
Question 10, right? Item 10.
Item 10. Can you read item 10 to me, because I don't know which item is item 10.
Just wait a minute.
Oh, sorry, I've been talking and I I just realized that my microphone was mute.
Oh, it's okay. So you heard the conversation, right? I
did,
asked a
I did.
question and
Yeah.
Yang Jie said she dropped item 10.
Yeah. Okay, good, nice. So continue, please. And I was saying that someone's microphone has got a hushing background noise. I was wondering if you guys could please close your microphones and open your microphone only if you want to answer the question. So group 4, I was actually asking group 4. Group 4, can you share your results if you don't mind, Shirley? And can we go with group 4?
I was talking with Yang Jie. I don't know which group
Are we
she
group
belongs
4?
to.
Okay, go ahead.
Anyway,
go
you
ahead.
can continue.
Yeah, but we do finish one of the analysis, but I think it is Xiaodong that dropped the term, but we haven't reached that step, but we have finished the analysis of the third factor, I think, and and based on the results, the Cronbach's alpha is 0.823. So which is relatively high, and so based on the item total statistics, so we can see that for the last statement, which is computers are useful only for playing games. So for this statement, the Chromebox alpha goes up if it is deleted, but it is only slightly goes up because the alpha will be 0.824. So we have not decided whether we're going to drop it or not. Yes,
Okay.
so that's what we have got. Mm-hmm.
Good. Very nice. So how about group 4? Group 4, what did you find? Did you find something similar or different? Room 4, we're waiting.
I think maybe we are room 4.
Oh, you were group 4?
Yeah, I think so.
Okay, so
Yes.
okay, excellent. Group 5 then. Who was group 5? There were a couple of you guys in group 5. Do you remember your group membership?
Group 5 is 曹媛and Sun Jianli.
Okay, good. So you guys, can you answer, please?
We had the same outcome with the group of 4.
Oh, but did you decide to remove any of the items?
We just find that the item computers are useful only for playing games 3. The alpha is larger than the Chromebox alpha, but we haven't decided which whether it is to delete to drop it or not.
You haven't decided. Good. Okay, can I ask this question from the rest of you guys? Did you decide to drop any items for factor 3 or no?
Yes.
No.
Yes.
No and yes. Okay, those who say yes, what is your argument?
So the question number 10, computers are useful only for playing games. We found the Chromebook's alpha has slightly increased if we drop it. And the correlation is also positive. So we decided to drop it, and then we run the analysis again. Then the Chromebook's alpha has increased to 0.824.
Just a very small increase.
Yes,
Very small increase. Good. And those who said no?
Yeah, my Chromebox alpha for this was factor 3, by the way, was 0.823, and based on the item total statistics table, most of the last column, Chromebox alpha if item deleted, most of the values did not range too far off the original value. That's why I didn't drop it.
Okay, I see what you mean.
Yeah, I think the highest difference is that 786. So a difference of 0.04.
Okay, so you didn't drop it. All right,
Yeah.
Nice. Okay, so as I mentioned before, guys, if the correlation is positive, but if Chromebox alpha, if item dropped and Chromebox alpha goes up, then you can drop it. But by how much? There's no rule of thumb or no gold standards here by how much. If you feel like there is a significant improvement in Chromebox alpha, then I by all means drop that item. But if you feel that the amount of increment or increase in Chromebox alpha is little, so it's not worth dropping an item because it can affect our measurements, then I think you can keep it. In this analysis, although some of you have decided to drop it, my personal preference would be to keep it for the time being because our sample size is large and also the amount of increment or increase in Chromebox alpha is pretty minimal. So it's not worth dropping an item just to make a very minimal change to Chromebox alpha value.
Yeah, the increment was 0.001.
0.001 is very small, almost negligible. Very nice. So what I'm going to do is to run the analysis on the last. Did anyone do the analysis on the last factor, by the way? Factor 4?
Yes.
Oh, okay, so I'm not going to do it. So go ahead, please.
If I'm correct about the number, which is 9 or 2, 9, 22, 23, and 19. So the Chromebox alpha is very low. It's just 0.570. And
Did you analyze all of these items?
yeah, 2, 9, 22, 23, and 19.
2, 9, 22,
22,
23, 19. That's
19.
correct.
Also, the alpha is low. It's just a 570, a 0.570, and
Did you find any negative correlations?
no negative ones. And all the Chromebox alpha, when the items deleted, all shows decrease, but a little bit.
I see. Okay.
I don't know what to do.
Okay, so I'm going to run the analysis on the last one because all of you have done the other one, and so here I'm going to also answer your question, and because you said you don't know what.
Dr. Vahid, can I ask a quick question?
Sure.
For factor 3, right, the Cronbach value was 0.823, and I mentioned that for the item number 3 that it increases by 0.001, right? What possible kind of range, let's say from 0.823, when it increases by, then we consider it as a significant increase to drop a certain item?
I'm afraid there is no, that's a good question, but there's no standard rule of thumb for that.
Based on your interpretations?
My interpretation. I think if your Cronbach alpha is, let me go back to those criteria I mentioned. For example, if it's in the medium range, it's below.
So it changes the range, is it?
Yeah, if it just suddenly moves from medium to high, I recommend to, that's a significant thing.
Okay.
So then you can justify it. You can say based on someone and someone who proposed this criteria, by dropping one item, I move from low to medium, or I move from medium to high in terms of Cronbach alpha, then it makes sense.
Okay, thank you very much.
But if it's 0.01 or something,
okay,
it doesn't make a lot of sense. So sure. So let's run the analysis for factor 4, this factor quickly, very quickly. So analyze, scale, Cronbach alpha, reset. Now, item 9, 22, 23, 2, and 19. Since I have reset it, come on. Okay, so go back to statistics, scale, correlation, and that's all about it. Continue, and okay. So the results are here. All the way down. Cronbach alpha, that's right. Liangli, that's right, is 0.757. And the correlations are all positive, which means that there is not a big deal here, not a big problem. But I assume this one might be a little bit of problem because the correlation is lower than the rest, as you see. If I'm good at statistics, my friends will think I am a nerd. The correlation is relatively low. Now, take this into account, 0.57. If I remove any of the items, I'm afraid none of them will change really. It will change the Cronbach alpha. It will just drop further. So I'm going to keep every item in this analysis. In the future, if I want to improve on the Cronbach alpha value for this scale, what should I do? I need to add more items to it, administer to another group of people, and hope for getting a higher Cronbach alpha value. Okay, so far, guys?
Sorry to interrupt, Dr. Vahid. I have a question.
Sure,
so
go ahead.
when we use the Cronbach alpha to compare the Cronbach alpha we get if item deleted, we use the first index instead of the second one, right? When we report the Cronbach alpha based on the standardized items.
Oh, 7. Okay, sorry. 72. No, I mean, you corrected me. It's a better idea to use standardized Cronbach alpha, which is 0.72. But in most cases, they're almost the same, or they have a very slight difference. But I prefer to use the one in the middle, 0.572. You're right. And in any case, in either of the two cases, still dropping any of the items will not save our Cronbach's alpha.
Okay, thank you.
Thank you for raising that. Now, there's one last thing, guys. Sometimes we have a question like investigate Cronbach's alpha across genders. I think you should be able to answer that question. Do you know how to do that?
Split the group.
Very good. How do I do that? I have this file. How do I split the groups? Where do I go to split first?
Data.
Data.
And sleep.
Split file.
File, yes.
And organize output by groups, right? And then I choose, for example, gender. And OK. Then if I run a Cronbach's alpha analysis this time round, which I'm going to do, reliability analysis for, let's say, oh, I have items here. So let me change the display. So, you know, for example, self EE1, EE2, etc. are measuring the same construct. So I'm going to choose 8 of them. This is another file, by the way. You also have access to it. I'm going to choose item and this, Cronbach's alpha. Okay. Now I will get statistics for males, which is 0.881 and or 0.886. That's better. Okay. Then gender male. So just ignore this summary item. Now this one is gender female, 0.861. So they're more or less the same. Now, is there any item to remove from the analysis? Not really, right? 6.1, okay. This one, right? 6.9, but it's very minimal, right? A one-page composition is very minimal. If I drop it, I don't see a very significant difference. For males, on the other hand, so that was for females. For males, whose Cronbach's alpha value was slightly higher, 0.886, 0.888, not a big difference, honestly. So I'll keep all of the items. Now, is there a significant difference between the Cronbach's alpha standardized for males and females? Not a very big difference, I would say. It's 0.886, whereas the other one is 0.861. It's still not too big, I should say. They're still within the high range. They're actually much closer to 0.9, both of them. So I do not see a very big deal here. Sometimes the problem is when the questionnaire Cronbach's alpha is high for one group, but is low for another group, especially when you want to compare them. For example, you want to run a t-test, or you want to run a ANOVA test. For example, ANOVA across the streams. There are 3 streams, as you know. So I'm going to split files based on not gender, but this time around based on, where is that stream? Come on, gender, ethnicity, citizenship. Okay, let's do it by citizenship this time around. I prefer this one. Okay, so analyze. We have at least 3 citizenships from what I recall. Let's see what Cronbach's alpha we will get for this instrument. The same thing. Okay. Now for citizenship, this is, you know, what is it called? Missing values. So we just ignore it, even though the Chromebox alpha value is high. I mean, we don't know what citizenship they have, so we just remove that from the analysis. Just move down to citizenships others. It has a high correlation, a high Chromebox alpha, 0.872. The other one is 0.877 for Singaporeans. For Singaporeans, others, I didn't see PR. So perhaps Singaporeans and non-Singaporeans, that's how it has been divided. Okay, so I think it's not too bad. Citizenship others 0.72, Singaporeans 0.877, which is pretty good. So the Chromebox alpha values are almost the same. Almost, not exactly. So that's good news. And there's no negative correlation. I wouldn't expect to see a negative correlation if you have a high Chromebox alpha value. And the rest of the statistics remains to be fine. 0.877, not a big deal. There's only one item which, if dropped, the Chromebox alpha value will only slightly move up. I would say it's not worth it. So let's keep it as is. For the rest of the other group, I mean, this is 772. Not a big deal. So I think we can still keep the items, because if you drop that item, it only will improve by 0.006. That's a very small amount of increment and doesn't make any changes to the level in which the Chromebox alpha values are situated. So we can just keep it as is. Now, you guys.
Hey, Dr. Vahid.
Yes.
May I remind you, you need to do the SFT today?
Oh yeah, thank you. Yeah, of course. That's a good idea. Just one last point is, you guys, please, go through the rest of the data that has been provided to you and run Chromebox alpha at your convenience. This is the data set that is available. So any of these data sets, 3 of them are available on Blackboard. Now, as you know, we have to do an SFT, as Shulian also reminded me. Please open your NIE app. There's an NIE app. I'm going to stop this recording and we'll leave after I provide you with explanations. Oops, where is?
Or ordinal, right?
Yeah, ordinal and interval. That's one of the advantages of Chromebox alpha, because prior to Chromebox alpha, I have mentioned this in my slides. Let me share the slides quickly, since you are bringing it up. Prior to Chromebox alpha, there were Kruder-Richardson and Gottman's lambda. Let me say if I don't have it here. Anyway, so this is okay. You don't have it here too. Anyway, so there were KR, Kruder, Richardson. I can write it here for you. KR20, KR21, KR20, KR21, Gottman's lambda 6 or lambda. They only were applicable to ordinal data and not categorical. I mean, sorry, not ordinal is not precise. Binary data only. Binary is something like, can you read that? Binary. So binary data, like those data that have only 0, 1 in them. There are only 2 digits. But when Chromebox alpha was introduced, they were retired because Chromebox Alpha can be applied to all of data types except nominal ones. Doesn't make sense to run reliability analysis for nominal data. Okay. All right. So now for those of you who have JASP, and this is the last portion of this evening's teaching, guys. Let me share my screen again. Okay, you can see the screen, the home screen of my computer. This is JASP. The latest version is, I think, 15. Mine is a bit old, but it still works. It still works like this, the same version. So if you click open on your JASP, this window pops up. This is extremely useful, especially because you guys may not have access to SPSS in the future. JASP is free and it's a wonderful software package. They have worked a lot on this. So once you are here, you need to open a data set. You can go to open a data file and take JASP for a spin. This window pops up. Click on, if you haven't opened any recent files, I mean, you can open SPSS for you as well. But let's go to data library. Data library is always useful because it provides you with all sort of free data sets. So you have data library for all sort of analysis. For example, for reliability analysis, number 13, if you click on it, you have this questionnaire, which I think is the same question. Yeah, SPSS anxiety question. That's what a coincidence. Good. So you can run the same analysis to see if we get different results. So just click on it and it opens it. I don't know if you have the same data. Do you have access to the same data, guys? Or not? Okay, so I am gonna move these items back. Okay, and just let me refresh my memory. The first factor included 8, 11, and 17. So I'm going to choose number 8, number 11, and number 17 and move into the variable side. Just like SPSS. Now I'm going to scroll. So there's a problem. Let me change the resolution of my computer. Display setting. Hold on a second, guys. You're going to see a different resolution. Okay, good. Okay, so JASP has got a different resolution. Now, I think you can see it, but it's small. I hope still you're able to see it. So what I'm going to do is to choose Chromebox Alpha. As you can see, is 0.819. What was Chromebox Alpha in SPSS, guys? Do you recall? Maybe you should refresh my memory.
Dr. Vahid, can you also choose the McDonald's?
Sure. McDonald's Omega. Okay.
Omega, so we can know how to interpret it.
So it's the same, actually. Most often they're the same. It's a very interesting thing, but it's a new thing. So some people say it's more powerful in the sense that it also gives you an idea about the validity of the questionnaire. But most often this is based on my personal experience, most often they return more or less the same values. They're not very much different. Now, since our data is not binary, of course, we can choose Gottman scale here, lambda, and Gottman's lambda. Oh, there are 2 of them, lambda 2 and 6. I didn't know about that. So you see, lambda 6 is quite smaller. I don't trust this very much because, as I mentioned before, this usually refers to binary data. So I don't trust this very much. and I just unclick this. So now you have got Chromebox alpha, and I can also click on omega if item dropped. Further down here, if item dropped, Chromebox alpha doesn't improve at all. Can you see that? And in the same way, in SPSS analysis, I think none of the items, if dropped, would increase Chromebox alpha. In the same way, you can see the same thing. So guys, what was the Chromebox alpha value in SPSS for this scale? Can you remind me, please?
It's the same. Yes, 0.819.
Okay, excellent. So this is how you can run the analysis. And I'm gonna open another, I'm gonna open a test for example, ANOVA, just to show you how ANOVA works, like alcohol attitude. Okay, good. So it's opening it now. This is the last thing, the last analysis, guys. We still have participants. Oh, what is this data? Repeated measures ANOVA. No, this is repeated. That's not what I was asking for. I just wanted to have a simple. Okay, I'm gonna open one of the files I have recently opened for ANOVA. For example, this one. I hope it works. Let's keep our fingers crossed. So it's a bit slow on my computer. Okay, so I'm gonna run the ANOVA. All right, good. The dependent variable here could be, oh, I have so many items here. Okay, so let's say my fixed factor is stream. My dependent variable is PSLE. That's an exam. Okay, so you immediately get the results. That's a cool thing about JASP, guys. You don't have to wait for SPSS for another file to pop up. Now, you can get descriptive statistics. You click and it populates immediately. Estimate of effect size, partial eta square is the best one. So you click and it populates. Can you see that? You immediately got partial eta square. Now you can choose the model, assumptions checked. You can check homogeneity test. Is homogeneity violated or not? Do you remember, guys? Based on this p-value, is it violated?
Yes.
Yes, because it's smaller than 0.001, right?
Yes.
Good. Now, if it's violated, you can choose Brown Forsyth test or Welsh test. It will, okay, let me just choose, for example, Welsh test is more reliable. And the results will be shown here. So it's pretty much just exactly the same as the ANOVA test here, because the sample size is very large. So even though you use a test that doesn't assume homogeneity test, the results will still be the same for simple main effects for post hoc tests. Here you can do post hoc for stream, and you can do any of these post hoc tests if you like to. For example, Tucky has been already chosen. This is post hoc test for, this is Tucky, P-Tucky for, you can add Bonferroni. Some of those post hoc tests that we use, see the p-value also is generated again. CDAC or SHIDAC is also, has got its own p-values, but in most cases, the results are the same. What else would you like to have? Marginal means is EMM. Do you remember that? So you can get marginal means as well. That's it. You can compare marginal means to zero. Bonferroni. This is exactly like SPSS, if you recall. So Bonferroni, etc. If you work with this, you will find very interesting things. SPSS doesn't have machine learning. It has machine learning. It's using artificial intelligence. I have made videos about this, about one of them. I'm going to make more videos about this. It's got factor analysis. It has a lot more, guys. You can just click, for example, distributions, and you'll get it here. Where is distributions? I think this was here, distributions, here, and so on. So I think this should be good enough for tonight. I'm sorry for keeping you for a long time. It's 9:02. I think it's a good idea to stop here. And let me see if you have any questions, any last questions, concerns that you would like me to answer before we call it a midnight.
It's just a silly question. So we don't need SPSS anymore, right?
No question is silly. Don't worry. I would say
We could do everything that you have taught us in the class. So we don't like a baby.
I mean, everything that can be done through SPSS, almost everything can be done through JASP. Not only JASP, but also Jamovi. That's another software. If you don't mind, I can share my screen quickly just to show you how Jamovi also, I'm not going to run any analysis, just want to show you how it looks like. So here is my screen again. And this is Jamovi. Can you see that, guys? Mine is version 1.81. This is also very powerful, but it takes some time to open. As it's trying to open, I wouldn't say you should throw away SPSS. You can always use both and compare the results. Both of them are user-friendly. I love JASP a lot. In the future, I might run this course using JASP and Jamovi. The reason why I am not doing that is that I haven't found time to sit down and do a comparison between SPSS output and Jamovi and JASP output, because in the past, I have seen some glitches in Jamovi. Some of the results do not tally with SPSS, and I rely on SPSS more than JASP, to be honestly, at this point. But I should say JASP has got a wonderful team of scholars in Europe. I think it's in the Netherlands, and they are constantly working on it and improving it. I wouldn't be surprised to hear that in the future, the complete version of JASP would be sold at $500, you know. Yeah, and this is Jamovi, guys. Can you see this? And you can, in the same way, you can open data sets and so on. You can open your data set, and you know, it's opening an SPSS file. Now it just opened SPSS. This is wonderful. And you can run any sort of analysis you want to, frequencies, factor analysis. You can run reliability analysis and so on. It has got omega, alpha, everything, you know, it's cool. These two software packages are great. Okay, guys, so thank you very much. Any further questions?
Dr. Vahid, for Wednesday's class, would we be on Zoom or will we be going to the classroom?
That's going to be the last class, right?
Yes.
I'd really like to have a face-to-face class with you guys before we close this course. But again, I will update you on WhatsApp. Okay.
And for the final, it's due this Friday night, correct?
For Friday, sorry.
The final 915 final assignment is due on this coming Friday.
915.
End of the day.
Yes,
end of the day, right? Okay, thank you.
Yeah, that's for language assessment. Yes, sure.
Sorry, Dr. Vahid.
Yeah.
Just one last question, and
No
I checked your video about how to converting the Excel file to SPSS file.
Nice.
But it doesn't really show like how the Excel file looks like. Like, for example, if I collect my data from scratch, how do I make my Excel file?
Oh, so you wanted to know how to create an Excel file.
Yes, like if I have like several groups and several groups have several data, some of them are the same. And then if I want to compare them, how do I make an Excel file and then convert it into an SPSS file? And that's,
Oh, I see. I see.
yeah,
what you-
when I'm doing, I'm lost. So
Oh, okay. So, okay, I tell you what, guys, those of you who want to stay, they can stay. But if you want to really go, that's fine. I mean, this is the end of the class. So I'm going to explain this quickly to you in a minute, how to create an Excel file and how to do the analysis. But please don't feel obliged, guys. Don't feel bad. If you really want to go, just please feel free to go. So this is for those of you who need to know about Excel file. This is the first thing is we should create an Excel file. I mean, this is how the Excel file is created, right? And you can put a name, for example, my cool data, and open the data set or the sheet. There's nothing in this sheet now. I mean, it might confuse you and, you know, where do I get the data? Well, you don't get the data anywhere if you don't really have any data. So you have to start manually by including your data. For example, you can start by ID, then gender, then stream, then item 1, item 2, item 3, etc. Now for ID 1, for example, person number 1, you want to give him an ID of 1, 2, 3, 4, 5, 6, 7, 8, 9. It's quite tedious, to be honest with you. It's very mechanical and tedious. You see, I already made a mistake. It has to be a 10. So you must make sure that you won't make mistakes. And so I want to move everything to the center. So center aligned like this. I just click on that. Now for gender, I can say male. For example, I look at the gender, the first person is male. So then the second one is male. I mean, I should be consistent, by the way, because you want to convert them. So if you use capital M, it has to be capital M throughout, not small m. So M, F, F, M, F, F, M, M, just, you know, making it up. Streams, I have 3 streams. Normal, technical, for example, normal, technical, then normal, academic, express, normal, academic, express, as an example, okay? And items, let's say for item 1, this is a questionnaire, a Likert scale from 1 to 4. Okay, so this person gave it a 1, 2, 3, 3, 2, 4, 2, 1, 3. And if you're curious where this data comes from, you have to have the paper questionnaires and you have to go through them one by one. So normally you should finish, let's say this is, I mean, you can drag this like this, item 4, item 5, and you drag it further, item 5, 6, 7, and it just populates it for you. So you normally have to finish everything horizontally, then go to the second person, then third person. So for the first person, I'm reading it from the paper questionnaire, and it's like this. Like that. So the first person is over. Now the second one, the second paper, and 2, 2, 3, 3, 3, 4, 1, 2. It would be a good idea to ask a friend to read it for you, to buy them a cup of coffee and say, in return, can you read this to me, please? I'll also add on a McDonald's pack of French fries if there are too many items for me to read. So, 3, 3, 3, 4, 1. Of course, that's not healthy. You can, for the third person, your friend might change his mind and say, look, I want something healthy like fruits. Do you mind? Okay, so this is my Excel sheet now. I mean, you should fill in everything for everybody. And from here, you just save everything here. It will be on your computer. And then the rest of the story that you saw in my video. Is that fine?
okay.
Good. So it's very mechanical and boring and kind of expensive for you, given that you're going to buy McDonald's and all that. Yeah. So it's going to be expensive.
Okay, thank you.
No problem. Okay, any further questions, guys? So I hope you will not have nightmares of Pearson throwing data at you or You don't feel like you're stuck under a normal distribution. Oh, I really have one point to share with you, because we have been talking about developing a good questionnaire. What I wanted to say is that the first question is double-barreled. Okay, it's double-barreled because it has two parts. And it's also a bit loaded, or loaded, yes. I wake up under my duvet thinking that, what if we do not really have a blanket? For example, in Singapore, we may not use a blanket when we sleep, right? So this part may not make a lot of sense. I am trapped under a normal distribution. I mean, I may never have this dream at all. I may have a different dream. And then another problem is this. This is very confusing. People try to tell you that SPSS makes statistics easier. What if I say no to this, or yes, and my answer to the second part, easier, but it doesn't? This is, you see, but this is precisely a double-barreled item. It's a problematic item. I wouldn't include this in the analysis, because the answer may not be the same. Your 2 to this item might be different from my 2. I might have considered the first part of it when choosing 2, and you might have considered the second part of it when choosing 2. SPSS doesn't know that though, but we do. So it could be reliable, but not valid. It could be reliably invalid. Now think about it. It could be reliably invalid. Okay, what does that mean? For example, it's like 2 people think that this is a pot, because both of them agree, they're consistent, so the judgment is reliable. But is it a pot? It's not. It's a cup. So it's a mug, actually. So it's invalid. It's reliably invalid. Okay, guys. You can go through the rest of the items and find problem items. You'll be surprised to see that reliability doesn't mean validity. There are always problems. There could be problems, not always. Okie dokie. So have a great evening, guys. Goodbye. See you next session.